Hello, hello. Hello. Yeah. Good morning, Tor.
Morning.
Yeah. Nice. I remember this office. You are at the company.
Yes, I am.
Okay.
Everything is more or less back to normal here in Denmark.
Everybody here? Okay, good. Boon, good morning. Good afternoon. And we're still waiting for James, right?
Yes.
James Sangali says that he will join if he has time, but because this is low priority, he may or may not join.
Hi. So you have a working computer. That's good.
Yes, yes. I have my desktop computer, and actually I repaired my laptop. It has a secret button that allows you to reset it to the original status.
Yes. Good old ThinkPad.
Okay. Yeah. So we're good to go, right? Everybody's here. Okay. We're going to continue building the TokenScript for attestation. Last time, last TokenScript meeting, the topic of last TokenScript meeting was whether or not we should have the module to define like the level of abstraction between module and data. If to let you remember where we were talking about last time. So this is example redeem by email action card that it allows you to redeem a certain amount of money through the email. Actually, this is the creation of no, actually, this is action card is Alice card. Sorry, this is Alice card that allows you to have an action that creates a check. And the way we do that is we have the module of the check defined here, and then we have a view which contains the JavaScript, and the JavaScript has been injected with dynamic API that allows this attestation, this check to be created. So last time we played with this idea, like stuff like this. Okay, stuff like this. So basically, you might have this. Was it let? Check. You might have stuff like this. This is not a JavaScript idiomatic. I'm just showing the thinking here. That is, we provide dynamically injected code that allows users to initialize a class check and set the amount and set reader and finalize it without JavaScript has to assemble the stuff to be signed. So you access the API instead of actually preparing the data to be signed. Not like this. Okay, so so the idea is once you have defined data model, you should be able to get a dynamically injected API that makes JavaScript developers work like this, and not let them hand assemble the data and hope it validates. I think that's where we left last time, right? And also, I think, remember last time, James Brown is also supportive of the idea of dynamically injecting API code that is generated from the schema.
Yes, I like that idea.
So which means that you like this one over this one, right? And that's what we were yesterday, last time.
Yes, it does mean that the developer is going to have to be more familiar with how injection works, and he's going to have to know it's less self-contained, but it's quite a lot safer, I think.
Yes. So every view will come with different injected code.
Potentially, yes, if you need to.
Okay. So today we continue from this conversation, and we look at how this how this view gets its data, because in order to have such a check, the view has to understand from which contract this is applied to, because that's part of the things to be attested, that which contract this attestation can be applied to. And look at line 21 and 29. This section is actually old. We already have this. That when you write a card, you can specify which token this card is based on. We had this in the X-die to die bridge, I think, right? We had this in X-die to die bridge. Do you want me to show this?
Wait, sorry, could you repeat that? The
Okay. Let me show you. Let me show you. First, I should be able to get this code from examples. Okay. Action only TokenScript X-die bridge. Okay. Stop sharing. Shared screen. Okay. Does this look familiar to you? This one.
yes, that one does. I thought that's what you were talking about.
Yes.
But, I see what you mean. Yeah, you could your code wasn't showing it, but you could be doing it that way. Yeah. Okay, got it.
Okay, but my code actually showed. Okay, let me show my show the code. Okay, so if Alice wished to create a check that allows Bob to redeem 1 ether, Alice has to have this action available on his wrapped ether token, right?
Yes.
Therefore, line 21 to line 29 is telling the wallet to put the action on the wrapped ether.
Yes. Yeah, that's standard TokenScript. How is that different?
No, no different.
Yeah. Okay. Well, I thought you meant the you were talking about having native chain actions.
No different. But I'm going to come to the things that are relevant. Okay.
Okay.
Okay. So this is how it works. On the left side is the email attestation token. And
oh, I see. So that you mean so this input token, this is like an equivalent of using value. So when you use value in the as an input in the TokenScript, that's like actual Ethereum or actual XDAI. So instead of that, you're saying that the input has to be this particular token.
Yes.
This ERC20. Yeah. Okay. Got it. Yeah. Okay.
You can do this. You can do another TokenScript with XDAI in it too, as long as you have a way to let the XDAI redeem by email.
No. Yeah, I understand. Okay.
Okay. And here is the email attestation module. Okay, so this is similar to the one you have seen before, and then we need a third one, which corresponds to the check that is created here. So there will be three token scripts. The third one, check, I haven't written, but this action card will create a check as the output. This action card allows Alice to create a check, which allows Bob to redeem 1 ether. And the input of that is wrapped ether or XDAI or whatever token that you allow the other person to redeem. And output of this is a check. So here we have signed check, which creates a check. And then we need a token script for that check, which uses the check as input data, and through a email attestation, generating a redeeming link, a redeeming transaction that redeems the 1 ether. We don't have the token script for that check, but we need 3 token scripts in total to support this scenario. And this is what we have so far. And let's move on to the next one. Yeah, this is the next one. Okay, so first, I think I made that argument last TokenScript meeting, but I actually didn't implement that thinking in TokenScript schema. Maybe I was drunk when I did that. So the thinking is, you do not need to define attributes in a token card if it is covered by the module, because all the elements needed in the module is already defined. You don't need to define, for example, data type or syntax, or whether or not you don't need to type the attribute. You probably still need to provide an origin for that attribute if needed, but you don't need to define the type. And then if your card is about a attestation or a event, then you don't even need to define the origin because it is implied. Does it make sense? So for example, if you have a token card that redeems, if you have a token script card, action card, which allows you to redeem 1 ether based on the check Alice sent you. Suppose you are Bob and you have this token script which has the rules allowing you to redeem 1 ether if you receive a check from Alice. Then you do not need to define the amount attribute or the expiry in your token script, because it's already covered by the check, by the module of check. When you define the module of the check, it's already defined, like how many elements should be there, what type are they, whether or not they are optional, whether or not they are an array with unlimited numbers. You already have those. So you should be able to use them in JavaScript as is. Make sense?
It does. Okay, so that will all be in the other token script, or from the return from the smart contract.
That will be exemplified in the token script of the check.
Yes, the attestation.
Yeah, where you can read stuff from the attestation. But apply the similar thinking here in this token script. This is the default ERC20 token script. So in this card, this is the activity card. And the input of this activity card is the event. then we shouldn't need to define attributes like right? The very fact that this card is based on the event, this activity is based on the event. The fact that this activity is based on the event means that you can get the events.
Yeah, sure. Yeah.
That object is already
Yeah, got
defined
it.
somewhere, right? It's already defined at the beginning, like these. So when you define activity, sorry, I lost where I was. Yeah.
Then you can use all of the other things you can use all the other parameters from that event.
Yeah.
In your, just as parameters inside the actions of the card.
Yes.
Yeah. Okay.
Yes.
That makes sense.
In this case, because when you define the data structure, it can be structured data. It means
wait,
you will not only get attributes.
Just one thing.
Also get attribute, which itself is structured data.
Okay. Okay. Just one thing. So this implies that when I construct the view, I should also inject. We should be injecting all of the parameters from the event as attributes into the view. Is that correct?
Yes, but imagine a scenario where you have more than one input. So actually, the input itself is an object to be injected.
Yes. That's
not the attribute, because okay, this is simple. This one only have one input, right?
Yes. Yes, it only has one input. But the thing is that that event, if you scroll up a bit, you can see that the event has lots of the event module description has lots of other parameters. Like, yeah, here we go. We've got all of these. So what I'm saying is, do we want owner, spender, and value as attributes injected into the view when you have that, when you've referenced that module as an event? Does it make sense? So that the TokenScript author can use those values as attributes.
Yes, they can
in
use
his JavaScript
as attributes, but not attributes of the card. I make the argument because the input might be more than one. Let me show you.
Okay, so you got to dereference it.
Sorry, I couldn't show you. So let's say this one, okay? This one only have one input, which is the event, which is nice. Imagine you have check, and there is a redeem action in the check. That action will need to access the check because it's implied, it's defined in the check. Of course, check is one of the input. But that action also needs to access the email attestation. So you get two things: email attestation and check. Both are signed data. None of them is a token, but you somehow depends on both of them to generate the transaction, right? So if you build that, moment, let me save this one. Sorry. Okay. It's really difficult to say if I should start with check or not, but let's say Actually, in this case, there's only one input.
There's more than one when you have a fallback to a smart contract function.
I'm sorry?
I remember we talked about when we'll have multiple origins, events, and smart contract function calls. That's when you would have more than one input, right?
Oh yes, that's one scenario. But the other scenario is you have more than one token as input. Wait. Anyway, let's look at the API here, okay? Let's look at what is in there. So forget about this. I have highlighted this. This is the activity. If we take that thinking that the module defines the data structure, therefore you don't need to define attributes if it's covered in the module. Then what is in JavaScript? So let's think about what is in JavaScript for the line 105 to 120. So instead of getting web token, what is the current way to refer to it? Sorry, I forgot it. What is the current way to refer to an attribute?
Data.
Current, right?
Data.current instance.
Token web3 dot data, or what is top level?
Doesn't matter. Make up something.
Web3 dot token dot current dot props dot this dot amount. Okay. Instead of this, we do this. Let's say transfer approval. So from address. Okay, we do this input dot input dot input approval from. Actually, I will use two because otherwise from is strange. Two. From input. Yeah. Now, this refers to this structure. The line on the left side, the JavaScript on the left side refers to the should be inside the right section.
Quick question: is input an intrinsic, or like we use it for in other places, or could it be anything?
What do you mean intrinsic? It is injected.
Intrinsic. So is like the keyword, is input a keyword, or is it a name? Because we use input as a keyword in other places. Yes, 108. To me, it's like input is an intrinsic in other places. So is it an intrinsic here, or could I just put TS colon, I don't know, initialize or something? And then that would, then on the left-hand side, I'd have initialize dot, and then whatever.
No, you cannot define new elements in TokenScript.
Yes, okay, so input is an intrinsic.
Mm-hmm.
Okay. So I can only inject at the root level, I can only inject intrinsic values. Okay, just checking.
Yeah, yeah. This is different from the card attributes.
Yes.
On the left pane, on line 22, should there be anything before input? Like web3.token something, or is it just input at the global level?
I don't know, maybe input at global level, because we are not opening this API to the web developers. This is only for TokenScript developers.
Okay. Why the subscript 0?
Oh, because I don't know. Maybe sometimes you have more than one attestation. That's an unlikely scenario. Maybe you have more than one token. If the user hand selected more than one token.
What if the same event approval? What if we need to listen for the same event called approval, but with different filters?
That better
Can
be
that
a
happen?
separate card, actually.
But for the same activity card. Maybe it's bad design on the part of the smart contract.
So the idea of the card is that when the card started, the input is already selected. So imagine you have an X die to die bridge. When you start the action card, you are already coming from the X die. So you already chose a token as input. So the scenario you described, so this card activity, this card, when you see this card, you have already chosen which activity, which event. So for your scenario to work, either we need to ask the user what is the second event to choose, or the user can multi-select, like a click and hold, select multiple event. Actually, no, this is activity card. So no, activity card is different. Activity card, I see why this is confusing, because activity card doesn't have input. So it probably should be written as base. Because activity card is not an action card. Action card have the input already selected. Activity not. Token card is also the same. Token card is not based on what user selected. It actually exists because the token exists. So maybe input is a little bit misleading here. or can you widen the definition of input to include base? But that's conceptually a little bit confusing because sometimes input is used for action where the user select input. And sometimes the input is, that doesn't mean user select anything.
What about source or origin instead of base?
Right?
Yeah, yes, or work. Source.
Yeah, that might work. Yeah, I don't have a set conclusion on this. This is something to debate and think about. I hope I can get this quickly because apparently this affects how the activity should be designed. This is an example where when you work on the activity, you suddenly realize that the things that you need to do with the actions and the test stations has something to do with the activity. And it's better to define, to think them as design them together instead of creating incompatible designs between them. And you are right, James Brown, that if it's source, then it shouldn't be under input. It should be a card attribute.
On the left, is it even necessary to have the word approval? Can it just be input or rather source.to?
If it's source, it might be, yeah, like .to, yeah. It might do, yeah.
That's
if
much
it's not
friendlier.
Input, then you don't need to say it.
Yes, that is. That's much more logical. Like looking at that from an outside point of view, I can see exactly where source.to is corresponding to. But so yeah, I agree. That's much easier.
Okay, but given that we already use origins to enclose Ethereum event in other places, and origins to include the Ethereum function call, we might consider the word origin as well.
Yes, but then would it get confused with the contract address? That's part of the declaration, the top declaration of the script.
You're right. Let me chew on this a little bit, and this is so far what we have. You have made a valid point. So let me keep source as it is for now. Now the last thing is before we have data module, before we have module like this, we could do nothing about rendering the transaction, but now we can. So let me give you an example. Okay, here's the data module. So if we're generating this data module from, if we're generating a email attestation, we know how to do that in action card. But if if imagine this, instead of being the email attestation, what you are seeing here defines the data to be used as a transaction parameter. Similar to, actually, this is not the best example. Yeah. Oh no, sorry. Okay, similar to this one. If you have the data object defined for a transaction, then even if the transaction is generated from a debt, Alpha Wallet understands what's in the transaction. For example, let's consider a tech model where you build a new USD token. You call it JBUSD, meaning James Brown USD. And you say that this is like CUSD and USDC, except it's better than both. And then you build a debt website, which asks you to sign the transaction so that you can allocate some of your DAI token into JB DAI. And you will write that allocate 30 DAI into JB DAI. And note, this is not ERC20, because you actually have to use authorize first. You have to approve a contract first in order to do that. And it's the other contract pulls money from your, pulls AUD DAI from your DAI contract, not you send DAI away to the other contract. Then let's suppose this debt site is evil because James Brown is evil. Then the user will actually sign the transaction that sends all of his DAI, which could be 1 million DAIs, to James Brown's contract. Then he will siphon this out. Now, suppose there's a TokenScript way to render transaction by defining the data module. Then we should be able to parse the transaction and show the user what is going to happen with that. That's right, right?
So you're saying that the user trusts the TokenScript file, but not the debt.
Yeah, I know it's kind of difficult without DVP security for the reason that I will explain in detail later. But let's suppose you are simply having a TokenScript for the token you already trust. And the website wants you to send your token to another one. Then by the courtesy of having the TokenScript for the token you already have, you know what this website is trying to do to that token. That at least guard you from sending your DAI and any token that is already in your wallet that has TokenScript away, or doing other things like authorizing your card to be used by a stranger, because your card TokenScript is already there. The card TokenScript has an action that allows you to authorize your card to be used by someone. And all knowledge for this action to work can be used to reverse pass such a transaction if that website asks you to do so.
But this is for any kind of transaction using TokenScript, isn't it?
Any type of transaction happening on the token you have that is defined by TokenScript. If you, by defining authorize car action card, you also prevented any website to authorize cars accidentally for the user.
Yes, but this property of TokenScript is already present before we introduce modules. As in when the user is prompted to sign a transaction, just a confirm button, action card transaction,
No,
we can already do that.
So sorry, I mean, if the user signs on the debt, now can you start again?
Oh, so if a debt just prompts the user to triggers a action card action, just a simple transaction.
Of course.
Yes.
So
yes. Right.
So yes, we want them to call the action, but if the website insists on doing it themselves, we cannot get rid of Web3 interface so easily.
Oh, so you are saying that you want to offer dApps a way to sign a random transaction, which is not composed by the TokenScript engine.
I really hate that to happen, but this is already happening. So I wish to not remove the current website's capacity to generate random stuff and ask the user to sign, because too many websites already use that capacity and we cannot cut it off. So when that happens, at least we can capture what is being signed by fitting it into the data module.
Can you give an example why this is necessary?
Okay, let's say the car example. So the proper way to rent your car to a stranger is to call the card, right?
Yes. Yes.
But before the car token script was created, the car token is already created by a company called TokenScript. The founding principle of that company is that they just create a token without TokenScript. And they have provided a JavaScript library, which allows a website to run the business car rental that will pop up transaction if the user chooses to rent his car. And that transaction is assembled by the JavaScript library supplied by TokenScript card token thing.
Okay, but if they do this and we let the TokenScript engine sign it, how would the TokenScript engine know which function is being invoked?
We don't. We passively interpret what is being signed, and warn users that this is pretty dangerous.
So, for example, if the smart contract, if the smart contract has 3 functions being defined, and so you're saying that the TokenScript file has to define these 3 functions in order to be able to detect which one is being used? Is that what you're saying?
Yes, we kind of, currently we don't define what is in the 3 functions. We define what to pass to these 3 functions. We define the data, we don't define the module.
Right, but we have to define the 3. Yeah. But we have to define the 3 functions in order for the TokenScript engine to generate the signature to figure out which one is being called?
Yes.
Okay.
Which we do.
So far, this is not something to be implemented anytime soon. It's just that, now we are capable of doing this, but we don't have to do it, and we don't know how much security we are adding to the user. We hope the users use card. If the user bypass the card and sign transaction anyway, even if we can display some of the information, some information might not be valid anyway. Imagine if the hash is used in transaction, then you cannot see what is before the hash, right? So card is irreplaceable.
Right.
This is just a thing that we don't have to do. Yeah, but might. Yeah. Okay, so I think that's all the topic I wanted to cover. Yeah. Is it all good?
Yes. Do you have time for question?
Yep. Yeah, you can always stay on the line. I'm just saying that anyone who has busy for something else can already leave. Okay. Tell me.
Great. Can you open the file with the module definition? I think for check probably, where the elements type is not Ethereum.
I just closed that window. I need to open it again. Is this what you want to see?
Yes, the one on the right, for example, line 15. Amount is type ASN integer.
Yeah.
So earlier on you were talking about input or source, where we don't have to define the attribute.
Yes.
When we do it with these types, which are not Ethereum native types, could there be some kind of mapping issue?
Yes, we might define the Ethereum type too. We might, or we might choose to define the API in such a way.
Okay.
Yeah. Yes. Okay. Yes. Tor, are you still online?
Yes, I'm still here.
Okay. So I asked a contractor, I don't want to use James and Boon's time, who is a JavaScript person. I want him to, and he's very familiar with not cryptographic, but the general knowledge of data setting, data schema stuff. And he's pretty good in terms of intelligence. So I asked him to produce some kind of API like this from 36 to 41, and let Boon to review if it's good. And if he can produce this set of API, dynamically generate this API for ASM module, then I will ask him to create the API, which is by dynamically generating such an API through reading the module like this.
Yeah.
And in the meanwhile, we need on our side to generate the Java code to comprehend the data created by such JavaScript API.
So the data created by the JavaScript API in this case, I guess, that will just be. I mean, that would then be internal internal JavaScript.
No, it's going to be like
yeah,
this.
and then it's going to be and then pass to ASN ASN, right? As a BER, DER, or something like that.
It's already ASN1 data.
Sorry?
It's already ASN1 data.
Yeah, okay. So you mean the Java part interpreting the AS1, the ASN1 data based on a data structure that's then in this case described with XML, right?
Yes. So what we need is a ASN1. Okay, we need two things. First, we already know that we need a signer, right? Which takes the data object as is and sign it. Hello?
Yeah.
Yeah, we already know we need a JavaScript, Java based signer, which takes that object and turn it into an assigned attestation, right?
Yeah. But
that
that shouldn't be so bad if we just assume that it's correct whatever we're signing, right?
Easy. That's easy. Let's put a pin on the wall. Put it on the pin. We need to do that, like in the next month, or within next few weeks. We need to do that. That's clear. Actually, I will talk with you. I will send you the issue of making such thing, so that you can already start working on this. The other thing we need to do is if you think you are Bob in the second stage of the project, which is not in this month, okay, you receive a check from Alice. Oh, actually,
Yeah.
even if you receive a check from Alice, you probably should be able to parse the data in JavaScript too. Therefore, you don't have to render it with Java. So actually, yes, we only need the signer for quite some time. Yeah. We don't need Java to be able to read ASN.1 data anytime.
So just to be clear, I mean, the signer in this case is basically just taking whatever BI encoded. I mean, I don't see there's anything else needed besides basically just taking like the DOM, for example. I mean, you could the DOM encoding basically, you know, just converting the base 64 into the byte representation and just directly sign that, right? Or you mean that this?
Yeah, we should be able to just sign it that way. Yes.
Yeah.
That should be a very simple thing, right?
Yeah. Yeah.
Okay.
Like the thing I'm thinking is if I mean, when this needs to integrate. No, I'm just thinking about like the integration with attestation and things like that. But no, that should still be the same. Everything is just ASN. Everything is just ASN1. So yeah, that should be super simple. You can't see there should be any issue with that.
Yeah. Can we start from the other side? This is really simple. Can we start from the other side? Can we? You have the protocol here, right? So and then I already defined these XML schema from your data, from your protocol.
Right.
Yeah. And you might want to add something new, which is okay to this thing if you want to. I can commit the files to the repository so you can work on it too. Then can you produce two keys, Alice and Bob, and privacy key, the third key, and also attestation key. So you need 4 keys. And can you produce every ASN.1 example data blob that is used in the protocol, starting from the certificate signing request to the email address attestation, anonymized email attestation, then to the redeemed by email check, Yeah. So with the 4 keys, 3 ASN.1 data objects, 3 ASN.1 signed attestations, and then we save them as binary file, and then I will use that to later test the Java signer as well as the JavaScript API.
Okay.
I would write a issue in the blockchain attestation, and list the data objects we need, and you might create them with a program or just hand create them, whatever. But once we have these, test this with the virus data.
Are all these, are we more or less final on the design of these the formats, like of the data objects themselves? Or
so the actual format of data object, like I provided in the example, from line 14 to line 17 is just the example. As you produce the test or that data object, you also produce the correct data object. For example, here I use the bit stream, but maybe you want to use octet string, because here I use octet string. The reason I sometimes use bit string, sometimes use octet string is because I haven't made up my mind either. So you probably are in better position to decide.
All right.
So actually it's the definition of all the data object needed, as well as examples for them. So actually there are two jobs. One is the correct data modules, and one is the correct, the other is the. I will upload this to the GitHub so that you can modify these stuff until you are satisfied, and then you create a binary blob for testing.
All right. Exactly the amount, or I guess you're going to specify that a bit more, like exactly the amount of of which kind of testing you want to do. I mean, basically, you want me to basically just implement this, implement the protocol, right? And ensure that it works with those specific formats.
Yes, which is the format that you help to produce.
Yeah.
Okay. Yeah, sure. That's the intention. Yeah.
All right. Just if you write like a test description, then I'll have a look at it. Also, while we're talking about the blockchain attestation, I took a look at your pull request. And approved it, and I made a new one because I was checking like the syntax and the consistency of the different things, and there were a couple of issues. So I made a new one. I also made the README file. So I made a pull request for you to have a look at also in the blockchain attestation on GitHub.
Yes, I see you. Thank you very much. That's really valuable.
It doesn't have to be now. It was just in case that that the email had like that you didn't know. So that's why I just want to say. Also, I wanted to mention like this.
Change, right?
Sorry.
Some of those are format change.
Yeah. So there are some issues. So I wrote both in the pull request I approved to you and in this one. Some of the issues that are like in particular in regards to the format specification itself.
Nice. I will carefully check them. Thank you very much.
You're welcome. Also, just to mention, I haven't had much time. I haven't had time last week to work on the backup, but like the state at which it is now is that it works with the threshold sharing, and like what I need to do is integrate with some database and make those work before we can start running, like actually running some tests and see if it works.
Great. That sounds like really good.
We are in our own branch. We're implementing two-factor authentication soon. So I might be able to steal some of the code from there, hopefully. So that would hopefully come for free.
Nice, nice, yeah. Okay, that's very good. As you change the attestation XML file, I will try to regenerate the corresponding ASN representation using the translation engine. You know that I contract this Indian guy to make me a translation engine to translate the XML1 into the ASN.1 format so I can read it and potentially useful for other applications.
Where's that engine? Is it on one of the GitHub pages or?
It's let me find it. Okay, it's actually in the branch, so that's why I didn't see that. I probably should move that one into into the main branch. So have a look at and I should make a pull request to make it into the main branch. So have a look at the branch called identifier attestation TokenScript.
Yeah.
And inside there's a TokenScripts folder.
Yeah.
And then you have there ASD XML to ASN.XSL.
All right.
This is a translation rules to translate the XML into the.
Okay.
Yeah.
Cool. All right. Thank you.
Okay. Since you made modifications, these translation rules might need to change because you might trigger the bug in the translation rule. But we already have the Indian guy to help us to fix it.
All right. Cool.
Okay. Thank you. I'll write an issue for you. Thank you.
Great. Thanks. Okay. Bye.
Thank you.